What is a resistor? A good definition might be this one. A resistor is a passive electrical component with a primary function to limit the flow of electric current. The standard symbols for resistors are given below. The zigzag on the left is the American standard, and the one on the right is the international standard by the IEC. To explain the definition more clearly, we use the example of water that flows through a tube. The flow of water is similar to the electrical current in an electrical circuit. The pressure difference that causes the water to flow can be compared to a voltage difference which causes the flow of electrical current. If we create a resistance in the flow of water, the current will reduce. We can do this, for example, by making the tube more narrow at a certain place. A resistor is pretty much the same. The resistor has a higher resistance than the connecting leads and causes a reduced electrical current. We can see this in the water pipe that a pressure drop is created because of the narrow part in the middle. The pressure on the left is bigger than on the right. The resistor has a similar effect. Here a voltage drop is created. The relation between the electrical current, voltage and resistance is described by Ohm's law. Mr. Ohm was a German scientist that discovered in 1827 that electrical resistance is equal to voltage divided over current. In this formula, resistance is in ohms, voltage in volts and current in amps. A simple circuit with a battery and a resistor can explain this. The voltage source causes a current which is limited by the resistor. The voltage source is 2 volts and we want a current of 4 amps. So what resistance should the resistor have? According to Ohm's law, the resistance is equal to the voltage divided over current, or 2 over 4 is equal to 0.5 ohms. An example of an application of this simple network is a basic LED circuit. Suppose we want to light a red LED with a 9-volt battery. The LED has a specified maximum current of 30 milliamps. If we directly connect the battery, the LED might burn out instantly. The LED practically doesn't create resistance, so the current will get much higher than the 30 milliamps. To prevent this, we can place a resistor at the positive lead between the battery and the LED. The resistor should have a resistance which is just high enough to reduce the flow of current to 30 milliamps. Using Ohm's law again, we know that the resistance is equal to voltage divided over current, or 9 volts divided over 0.03 amps is 300 ohms. If we now connect also the negative lead and create a circuit, the LED emits a nice red light. Using a resistor for an LED circuit is just one application, but there are numerous other applications and purposes for resistors. To give a complete overview would be absolutely impossible in this short video. There are a lot of different resistor types, all with their own applications, characteristics and construction. Fixed resistors have a constant resistance value and they are the most common type. When people talk about a resistor, they most probably mean a fixed resistor. The picture shows an actual carbon film resistor. Fixed resistors are available in axial and SMD packages. Variable resistors have an adjustable resistance value. Most variable resistors are adjusted by mechanical movement. When they are used as a variable voltage divider, they are called potentiometers. When they are used as variable resistance to control the current in the circuit, they are called rheostats. Digital potentiometers are controlled electronically instead of by mechanical action. The third category are resistors which have a varying resistance dependent on a physical quantity, such as light, temperature or voltage. They are often used as measurement devices. Another breakdown of resistor types can be made according to resistance material and construction. Wire-wound resistors are the oldest type which are still used today. They are constructed by winding a resistive wire around a non-conducting core. They can have very low resistance values and can be produced fairly accurate. Furthermore, they are very durable. A disadvantage is the parasitic reactance for higher frequencies. Carbon composition resistors are constructed with a mixture of a non-conducting ceramic and fine carbon particles. They are also very old and used to be the most common resistor type a few decades ago. Although their properties are inferior to other types, regarding for example tolerance, they are still in demand for certain applications. For example, they have the ability to withstand high energy pulses. Carbon film resistors are widely used today. They are made out of a non-conducting core with a thin carbon film around it. Carbon film resistors have a higher accuracy than carbon composition resistors, but have inferior properties compared to metal or metal oxide film. Metal film resistors have a similar construction as carbon film resistors, but have a metal layer instead of a carbon film. They have a better accuracy, a lower temperature coefficient, and a fairly good stability. Metal oxide film resistors are even more durable and have a higher temperature resistance and reliability than the metal film resistors. Foil resistors have a resistive element of a thin metallic foil of several micrometers thick. They have the highest available precision and stability today. Most actual leaded resistors have a marking with colored bands to indicate the resistance value and tolerance. This resistor is a carbon composition resistor with 4 color bands. The first band gives the first digit of the resistance value. The second band gives the second digit. The third band indicates a multiplication factor, and the fourth band gives away the tolerance of the resistor. You can try to memorize the meaning of each band and color, but you can also use the resistor color code chart to decipher the code. At resistorguide.com you can even find an automatic calculator to decipher the code for you. Using the chart, we see that the first red band has a value of 2. The second blue band is 6. The third band is gray, which means a multiplication factor of 10,000. The golden fourth band means a tolerance of 5%. We know that the resistor has a value of 2.6 megaohms with a tolerance of 5%.